Hi everyone, I'm
I'm
And I'm the video we watched to review the lecture was Cosmology and Exoplanets, unpacking the 2019 Nobel Prize in Physics. The Nobel Prize in 2019 was awarded to two different parties. The first one was James Peebles for theoretical discoveries in physics cosmology. The second was Michel Mayor and Didier Queloz for the discovery of an exoplanet orbiting a solar-type star. The video lecture we watched was split into two topics. The first was cosmology, study of the universe as a whole, and the second speaker spoke on exoplanets and how we've been detecting them for the past few decades.
So James Peebles was recognized for theoretical discoveries in physical cosmology. His award was for a lifetime of discoveries that included 40 years worth of published work. Peebles is now widely known as one of the fathers of physical cosmology. A number of his discoveries were highlighted in the video, including that of early nucleosynthesis.
In 1966, Peebles predicted that helium would form hydrogen after the Big Bang. And then he also predicted the formation of galaxies and calculated how small density fluctuations would lead to galaxies forming. And he also explained how galaxies get their spin and co-predicted with another Russian scientist the cosmic web, which is the structure of interconnected galaxies, and how they're high density points versus like vacuous areas. And that prediction was actually confirmed by a Harvard study that observed tens of thousands of galaxies that showed those patterns emerging.
Moving on to Mayer and Queloz, their work focused more on exoplanets, particularly exoplanets orbiting a solar-type star, so one like the Sun. Prior to that, the only exoplanets we could see were orbiting pulsars, which is not like a star. They're the size of a large city, but extremely dense.
And they're highly magnetized, like tens of
Right.
thousands times more
Yeah,
magnetized than the
yeah.
Sun. In the 80s, two scientists, Campbell and Latham, unknowingly discovered exoplanets because they found, they got some signals of the planets, but they weren't sure what the signals they got actually were from. They didn't know whether they were indeed due to other planets or whether they were due to a brown dwarf or anything like that. So it was never confirmed. And so they basically discovered them without knowing. And like I said, two planets were discovered orbiting a pulsar in 1992, but no planets orbiting a sun-like star were found until Mayor and Fellows in 1995, and they discovered 51 Pegasi b.
They discovered it using the radial velocity detection technique. They just detected variations and anomalies in how stars and different objects were moving. And then their discovery confirmed the existence of other like planets, which revolutionized planet formation theories and helped kind of fuel and kick off the search for habitable planets. And now we actually use a bunch of different methods to find exoplanets. So there's radial velocity, there's the transit method, microlensing, imaging, timing variations, and orbital brightness modulation. The main one now is actually the transit method, where we use line of sight to see patterns of when planets pass in front of stars.
Yeah, I thought that was interesting when Professor Lee explained that at the end, like how there's kind of like a sinuous curve when the planet passes in front of a star, it gets a little dimmer. That's
Yeah.
how we can kind of detect the period of its orbit.
I would have expected that people would think to use that first, because it's easier to just say something like you see it versus you have to calculate like radial velocity
And also supercomputers. They talked about the Summit supercomputer from Oak Ridge National Laboratory. Yeah, when that video was made, that was the best supercomputer in the world. That's actually been replaced recently by Fugaku in Japan. That one doesn't start operation until 2021.
Well, I was gonna backpack off that really fast.
Okay.
It being able to detect the exoplanets and find them even better than the supercomputers that we have now. That's just an increase how fast we're finding them, I guess, which I think they said in the video was already an exponential rate basically. And now we're at over 4,000 plus thousands of candidates that require further observation. It's just
Yeah. That data's from NASA, by the way, for all our listeners out there. And they found out that the number of exoplanets doubles every 27 months, number of known exoplanets.
Which fuels the idea of habitable exoplanets and the idea that what if there are other living things out there?
I found a lot of stuff in the cosmology half of the presentation to be really interesting. I don't know if you guys knew this, but I didn't know that the universe was made up of over 70% dark energy and then 24-ish% dark matter, which I thought was pretty crazy.
Did know that.
I also didn't know that dark matter was collisionless. So I thought that was pretty cool as well. And then,
Yeah. I just knew that we don't really know anything about it, you know.
Yeah,
yeah,
it's like kind of a mystery, but I would want to like look into more of like why it's collisionless, or like how maybe.
The only way we can detect it is its silhouette because it's not observable.
and I also thought it was pretty cool that there's still radiation from the Big Bang just radiating from everywhere in the universe right now in the cosmic microwave background.